recording.
So the sum and difference formulas can be found on your pink sheet, that formula sheet that I gave you. They're at the top. And we have the sum of an angle where you're adding inside the sign. This is the difference of signs. So you're taking the sine of two angles that have subtraction. Cosine, so sum of cosines, difference of cosines. So when you look at them, you just kind of want to understand what the pattern is. It doesn't really matter though, because you guys will have the formula sheet in front of you. But when you do sine, it goes sine, cosine, cosine, sine. So it's just a reverse of the two angles. So you do kind of get in the habit of thinking sine of the first angle, cosine of the second, cosine of the first, cosine of the second. But notice that when you do the sine formulas, the plus sign, they match. Also in the negative, when you're subtracting, those two match. And then when you look at cosine, it's cosine, cosine, sine, sine. But there it's the opposite. So if you're subtracting in what I call the formula, you're adding in the expression there. And then tangent is kind of totally different. But the plus signs match on the top, the negative signs or subtractions match on the top, and that's opposite on the bottom. So it's you add the two angles together on top, one minus their product, one plus their product over there. I don't develop it, I don't show you how it's developed, so we go right into it. So, find the exact value of the sine of 15 degrees. So what's the point of this? You look on the unit circle. Where's 15 degrees? What? Somewhere between 0 and 30, but it's not on the unit circle. Are there two numbers on the unit circle that I could add or subtract to get to 15 degrees? You can do 60 minus 45. You can do 45 minus 30. Right? There are lots of different numbers that you can use, and this is one of those times, again, that you might start in a different spot than somebody sitting next to you. So let's just do 45 minus 30. So I'm going to do the sine of 45 minus 30. So understand that we're switching the way it looks, but I'm not changing its value. We're still taking the sine of 15. But now, if you look at that formula again, it goes sine, cosine, cosine, sine, and it will match the subtraction. So we go sine of my first angle times cosine of the second. If it's subtraction here in purple, it will be subtraction here. And then you go cosine of the first times sine of the second. So now when you look at that blue expression, following the pattern, right? Those are all numbers that are on the unit circle. So, go to 45 degrees. What's the second part of the ordered pair? Root 2 over 2. Go to cosine of 30. What's the first number at 30? Root 3 over 2. Go to 45. What's the first number in the ordered pair at 45? Root 2 over 2. Go to 30 degrees. What's the second number in the ordered pair? 1/2. So the blue comes from the pattern right off the pink formula sheet. The red numbers now are coming off the unit circle. And then we just multiply them together. Root 2 times root 3 is root 6. 2 times 2 is 4. Root 2 times 1 is root 2. 2 times 2 is 4. So what's your final answer? Square root of 6 minus the square root of 2 all over 4. You can multiply under a radical. So if I was multiplying, I could say the square root of 12 on top or something, but we're subtracting. So we do not subtract under radicals. Now, one of the things that we can do is look at the calculator. I'm going to be in degree mode. So I can take the sine of 15 degrees. And that's the decimal I get. And what the test or whatever will say is give me the exact values only, no decimals. And so what we want to do is take the square root of 6 minus the square root of 2, and then we divide it by 4. So notice that the two decimals turn out to be the same. So that's a way to check your work at the end, because square root of 6 minus the square root of 2 all over 4 doesn't necessarily make sense to the problem. It's just kind of an arbitrary number, but you can check your work out. Find the exact value of the cosine of 7 pi over 12. 7 pi over 12. I will assume that it's going to be easier for you guys to work in degree mode as you do these problems, but what's 7 times 180 divided by 12? Because the pi's would cancel out. 105. So where's 105 on the unit circle? It's not. So give me two numbers off the unit circle that add up to 105. Or subtract, I should say. Either way, whatever you want to do.
40 plus 60.
What?
45 plus 60.
60 plus 45. What else? 135 minus 30. 150 minus 45. Lots of options. In this case, I'm going to pick this one, and the only reason I'm picking it is it's in the first quadrant, and most of you are probably better at the first quadrant. Plus, I know I don't have to worry too much about positive, negatives. So, the cosine formula for 60 plus 45 would go cosine of 60, cosine 45, sine 60, sine 45. And now with cosine, it's the opposite sign goes in here. So if we're adding them there, we'll be subtracting over there. Cosine, cosine, sine, sine is the pattern for your cosine formula. What's the cosine of 60? 1/2. What's the cosine of 45? What's the sine of 60? What's the sine of 45? So in red, those numbers came off the unit circle. 60 degrees, 1/2 to the left, or 3 over 2 to the right, so that's your cosine sine. Then when you multiply tops and bottoms, you end up with root 2 over 4 minus root 6 over 4 for a final answer of root 2 minus root 6 all over 4. So that would be your final answer, and again, you could go to the calculator, you can type in cosine of 105 to get the decimal, and then you can check that decimal. On a problem like this, put yourself in like the teacher's shoes and look at what some student has written down. What pattern did they follow? Happy Friday. What are they doing? Cosine, cosine, sine, sine. So it's a cosine formula. And because it's plus here, they're subtracting inside. So it's cosine of 78 minus 18. Well, what's 78 minus 18? So they're really looking at cosine of 60. And the cosine of 60 degrees is? That's it. So you're looking at their pattern. What did they do? So what should I do?